Good day, folks. Major announcement. It actually looks like we finally did it, folks. I found free energy in the sense that the system can get additional energy that we don't have to provide user input wise. Obviously, it's not free energy out of nothing. But with that said, I finally did it. And basically, a little bit of background on all of this is I found out about this method about 3 months ago, and I've been experimenting with it more and more. And it looked very promising, and I actually succeeded with it. And I've given actual demonstrations of how basically 70 MAs was running all these loads off the displacement current effect. And I basically offered a scaled down, very simplified demonstration of what Don Smith was talking about here. And it worked very successfully. And again, some people always want to see the self-loop thing for some reason, and I find that's actually the least important. And every time I post self-loop systems, it always gets to scrutiny anyway, so it never amounts to anything constructive anyways. The important part is being able to present the information so others can understand and follow along and possibly build these devices as well, and that's always been my goal. Now, with that said, I did achieve the self-looping and I didn't videotape it, but I do have a video and I will show you that next, that the system, as simple as it is, can support. Basically, the idea is displacement current will support a self-loop system. And this had me thinking for a final design. You see, Tom Bearden actually told us in the Energy from the Vacuum series that there's no rules in physics that tells you that you can transfer a joule of energy from capacitor A to capacitor B and back into capacitor A. Of course, minus the minor in-wire loss, so let's say minus 10%. So essentially, there's no rules that say you can recover 90% of that joule back into the original source if you do it right. So I started experimenting with that concept, and of course, not only experimenting, but over the course of the years, I've given you the theory behind it, the individual explanations and examples of the individual interactions with displacement currents. I've already also given you the revised Maxwell equations to help accommodate for these interactions. So I've given you the theory, the working foundations, and even demonstrations. So with that said, folks, I don't want to see any trolling on this post. Not only does this work and has been replicated and can be easily upscaled if you understand how this works, I've actually signed an agreement with a company to develop this. So really good news going forward. And no, folks, it's not bad because essentially what it means is those who really want this, who just can't figure out because it's so advanced. It's not for everyone, obviously. Very soon, maybe within 2 to 3 years, you'll be able to go into a hardware store and buy this as a generator. And of course, you don't need to be angry about, information being hush hush because when patents come out, individually, anyone can take a look at it and for scientific purposes can replicate it and use it at home. The problem arises if you try and make a company and sell it and profit out of it. That's when the lawyers of the company or any company would go back after you. But this was actually good because those who are still knowledgeable in this field but can't quite get over the lump will be able to see a complete pattern and go, oh, that's the detailed process. Okay, I'll do that. If you're well able, no one stops you from experimenting with this stuff on your own. So it's a win-win situation because I don't have the resources myself. And this is, of course, different from the Bedini concept, as good as the Bedini concept is, because with Bedini, you essentially, if done right, one battery can slowly charge two batteries. But it's not commercial quality power. This here I propose is 4.75 kilowatts hour, give or take maybe 10% of efficiency loss, but you're still dealing with a massive amount of usable energy for a little input, in my case, 500 watts, to give you all of that. So essentially, people who have tried to build this, they get confused essentially when it comes to the switching. The switching could be a million different methods. So this is where as a company we're going to focus on because all of this stuff, the reason I can talk about it is it's mostly already open source or common knowledge. It's just we're using clever ways to manipulate these systems. Nothing new here, just clever ways of connecting everything together. We can talk about that. But what we're going to do as a company is figure out a switching mechanisms in software, and the way I see it is we're going to license the software and that sort of thing. So again, switching mechanisms here is quite complex, and that's where a lot of people get mixed up because it's a precise timing and sequence. But if you understand how the system works, go at it and figure out your switching, and you've got it made. You can scale this up to um, any usable application you want. And the thing is, folks, you might say, the thing with Don Smith here is I recommend you read this document and read it completely. Don't try and just build the circuit if you don't understand what happens here. You need to understand, and I understand too that maybe only 10% of you will get it, but the 10% of you that do, you'll understand and you'll be able to make this device, assuming you have all the resources to make it the way you want to. Now, in my example, I use 100 volts. So people might go right away, wait a minute, this doesn't line up with Don Smith. Well, I explained that, and the thing is, Don Smith decided to use high voltage because high voltage is known, it's more efficient to transfer energy at high voltage, and he needed much less capacitance to get the same joule energy. But he gave us hints, like a 1 farad capacitor could give you 1 kilowatt or more without getting into the inner details. But then he'd show you his high voltage drivers, which are all variants of Tesla and resonance and things like that, which are great on their own. But everyone seemed to focus on the driver and not exactly on what was going on with Don's claims. And he would present slideshows showing all the transformers, but not telling you how he's getting 4 kilowatts out of it, just claim he would, and then show everyone something else completely that wasn't part of what he was talking about. But then would showcase, the high voltage stuff, that makes sparks and charges the capacitors. And he was right within that concept. But what he never shared is this is not the main, what people would consider the magic component. It was just Don Smith decided that, hey, if I'm going to drive this with high voltage because it's going to be more efficient, maybe I can drop that 10% efficiency loss a little bit. And since it's high voltage, I can bring in resonance and all that extra stuff in there. And the magnetics dynamics changes at high voltage. So by exploiting those systems, which is the like displacement currents through ground and all these tricks that you can do at high voltage, he may have been able to bring the efficiency. Instead of being 10% loss, he may have had a 3% loss. But the point is, you don't really need high voltage if you understand. It's all about joule energy and displacing it from one capacitor to another through capacitive discharges. And that creates, as per Maxwell's correction, which most people don't use, but he corrected anyways, if you do A, B, and C interaction, this is what happens. You get a displacement current. Now, the displacement current is not real current. It's not closed loop current. We usually consider it phantom current. But this phantom kind of current can induce a real magnetic field in a transformer that will, in result, induce another EMF on that loop, essentially decoupled from the capacitive charge-discharge mechanisms. So the displacement current happens to be an additional tap, which is there anyways that we wouldn't normally use. And on top of that, we're recycling that joule energy and sending most of it back into the source. And with the help of switching, we just initiate that cycle over and over again. And our battery, our main input source, only needs to provide 10% or less of that energy while running all these loads. So that's the Don Smith secret, but he never actually gave you those details, folks. So here I'm sharing it, and again, please read the document, and you will, those who understand, it's going to go, ah. But again, folks, I don't expect the mainstream to understand this. And please, no comments about, how to connect coil A into coil B if I instead do blah, blah, blah. There are vast possibilities here. I give you a framework to work with. It's up to you to do your research or find someone that understands how to build customized transformers to get your ratios right. But the point is, with very little loss, 10% or less, you could recover all those joule energy. So with that said, I leave it at that. And again, I'm really looking forward to putting this out there, but as far as the company, they're still working things out with lawyers and background and everything. And I'm eagerly waiting for this to finalize, and at that point, I will be able to make it an official announcement. and announce the company name and everything. But until then, folks, we're just proceeding as usual, and I'm sharing everything I can. And with that said, have yourselves all a great day. Thank you very much for watching and following me along the way.
Okay, so now I'm self-looping, connecting the power directly. Same setup here. Watch my previous videos. So I have it disconnected now completely because I'm looping it with the DC. This isn't even connected. There's nothing here. It's disconnected, see? Just because there's a lot of stuff here I've been working on, but it's all disconnected. This is the power for my phone here. And 8.38, and these are the, you see the scope, that's the reading off the microwave power supply right now. Very sharp spikes because of the high frequency oscillations. That's connecting directly to the microwave transformer here, and we're rectifying that back into the super caps, and we've got an increase in charge, 8.39. It started at 8.38 when we started. Just to show you the self-looping setup, it can be done. A lot of people wanted to know. So I'm not using this box right now. It's set to open. And there's nothing connected to these probes. I'm just showing you the consistent build up and charge here. And these are super caps. So now I'm at, let's see, I'm running these 500 plus 500, and these are 10,000. So altogether about 168 F. Trying to up the voltage, but it's the same setup. One plate on one side, high voltage, and then going into the high voltage side of the microwave transformer, and then the low voltage, just single diode rectifier. So here is the plus and the negative far out here. .4 now. So this is a lot of farads. So if you short this, it gets pretty hot. I don't want to do it there. Even this little motor, if I turn it on right now, it's too much at this point for it. But you did see earlier in the earlier video, running this inverter, we're getting nasty sparks here because it was continuously charging this capacitor. But now I decided, hey, if I can do that, I may as well try the self-looping, right? Because I personally think there's no application to it unless you do something more with it, right? I find it's better to run bigger loads than wasting it all on a self-looping system that does nothing else but self-loop. But it's not just self-looping, it's accumulating a charge. And here's the and if you're wondering, by the way, self-looping, it's not as powerful on the oscillator, so I'm not getting those tens of kilovolts of high voltage, so that's why I'm able to run the probe directly without all that zapping. But needless to say, enough to produce the effect. So 8.41 now. So this is right before the rectifier taps, so you're getting all the noise here, the frequency bursts from the oscillator. But it's doing a kind of feedback with the fields in this configuration, with the primary and secondary, with the one wire driving the high voltage side, and the secondary low voltage is being rectified, and it's sustaining the loop. I just want to keep talking here just to show you it's consistent. It's been about 5 minutes now. So remember, this is a lot of farads to charge. So the point that this is going up is like charging a battery almost. So of course right now I gotta shut everything off on the loads to south loop and charge it, because then I drain. It's not optimized, it's just a demonstration for the concepts. But if I were to optimize this, we're limited by our knowledge, parts, and accessibilities, and whatever you can do, your skill, right? But it's still going over here pretty strong. No drop at all. But it's basically just noise, the way it's set up right now. And that noise keeps feedbacking it. .43 now. Yeah, it's fighting it. So 7 minutes self-looping. Charge on the supercaps are still increasing. We still have solid oscillations. Now a switching mechanism would be nice. Be the second stage to dump this. It's serious energy with all these farads, actually. Bound to get 8.44 soon there. There we go. So yeah, we've been running for 8 minutes. Still going strong over here. And just in case you're wondering, oh, it's the scope powering it, we're going to disconnect the scope carefully here. Very carefully. I don't want to disturb anything. I can do it with one hand here. My scope is being stubborn. There we go. So now scope is off. So I'm going to look for a moment, 8.44. It's coming in pretty strong because the capacitor is dampening it, right? It's charging it up, but it's hitting it like at hundreds of volts still. I took the scope off there completely. I had a problem with the, it got stuck there, but I didn't want to screw anything up either. There you go, 8.45. So the scope is off. It's not the scope, people. Because I know someone always says, oh, it power's coming from the scope. No, it's not. And if you follow my earlier videos, and I recommend you do, it all explains how this works in details, and there's even circuit diagrams. So there you have it, folks. Nothing to see there, it's disconnected. So it's been 10 minutes, still going up on the supercaps. The only thing that's connected to them is the secondary of the transformer here and this meter, essentially. And no, the power is not coming from the meter. Please. So this is remarkable. It's charging the supercapacitors, the whole freaking bank. So we're not plugged into the grid or anything. There we go, 8.46. So I'm going to end it at that, folks. And again, if you don't understand what's going on, I highly recommend you watch my previous video uploads. The last few of them anyways really puts light on what's going on here. And until next time,